Hi. So today I'm going to talk about role-playing dimensions. So these are important modeling. They present important modeling situations which we need to handle. Right. So let us see what these role-playing dimensions are. So topics for today would include role-playing dimensions, the problems that they pose, and the solutions. And we also look at the synonym command, right, or the alias, and example modeling situations. So most of the material for this book has been taken from the Kimball's textbook. That is so role-playing dimensions. So there's a single physical dimension. A single physical dimension can be referenced multiple times in the same fact table, and each reference linking to a logically distinct role for the dimension. So for example, a fact table can have several dates, each of which is represented by a foreign key to the date dimension. Okay. Now it is essential that each foreign key refers to a separate view of the date dimension so that references are independent. Because once the references are, if they are not independent, then it can lead to several problems, as you will see. Now separate dimension views with unique attribute column names are called as roles. So our dimension, so this topic is all about a particular dimension playing multiple roles in the fact table. Basically it happens when the dimension appears multiple times in the same fact table, right? So let us now see what are the examples. So here is an example. So you can see order line items is the fact table, and you have an order date and a requested date. So if they were talking to the same, so there is one order date here and one requested date. So you can see here there is an order date key is here and the requested date key is here. So could not have joined them to the same date dimension. Like suppose if these two are not there and there is a single date dimension here. Okay, so what would have happened is that, so there will be a date key, okay, and then this date key would, so this order date key would refer to this, and so would this. Now if I were to join these two tables, like the order line item table, fact table, with this date dimension, so what this join would have required is that both the order date and the requested date should be the same. Then only it would qualify for the a particular line item would qualify for the join. So it is taken as a two-way simultaneous join, and this is what we don't want. Okay, so that's why we need to create this two copies. I mean, we'll start with two copies and later we'll see how we create not two copies but two logical copies of the date dimension. So role-playing dimension, consider a fact table to record the status and final disposition of a customer order. So what happens here is that dimensions of this table could be order date, packaging date, shipping date, delivery date, payment date, return date, refer to collection date, order status, customer order status, customer, product, warehouse, and promotion. So these are different dimensions, but you can see this order date, packaging date, shipping date, delivery date, payment date, and return date, and also refer to collection date, right? So these are all dates that appear in the fact table. So 1, 2, 3, 4, 5, 6, and 7. So there are 7 dates in the fact table, and they all refer to the same date dimension. Okay. So date dimension appears multiple times in the fact table. So whenever you encounter this situation, that means you have to model them as role-playing dimensions. Okay, so let us see how we do this. Now note that the first 7 dimensions are all time, and 7 foreign keys from the fact table to the time dimension. This is what I am showing here at the top. We cannot join these 7 foreign keys to the same table because SQL would interpret it as a 7-way simultaneous join as requiring that all the dates be the same, right? And is this what we want? So the answer to this is no. So what do we do? So what we do here is, so we cannot use a single timetable or a time dimension. Okay, so what we do is, so we want to administer at the same time. So one thing is clear, that we don't want a single time dimension or a date dimension. At the same time, we do not want to administer. So what I mean by administer is that build and maintain a single, at the same time we want to administer a single physical date dimension, because I don't want to create and maintain 7 or 10 copies of the date dimension, right? So I want to administer only a single copy, physical copy. So what we try to do is to create an illusion of 7 independent date dimension by using the concept of views or aliases, right? So what I do here is, so suppose this is my date dimension, right? So this is my date dimension. So what I do is I create a view, order date. Okay, I have a syntax later in the presentation, but let me order date dimension as select attributes from this date dimension, whichever you want, with whatever names you want, and you create that. So this is a view that is created. So I have created what is called as a virtual, because a view is a virtual entity in databases. So I have created a order date virtual table, or you can say a order date view. Similarly, I create another view from the same table, which is like packaging date, and I rename my columns as I want and I rename them in the view definition itself. So I create another virtual entity which is like this. Okay, so what we do is we create an illusion of 7 independent date dimensions by using views or aliases, and the column labels in each of these tables should also be different. And why they should be different? Because if I keep the same names and I drag them into a report, so I will not be able to differentiate whether it is coming from the order date dimension or the packaging date dimension. So the reason I've just explained, so we will not be able to tell the columns apart if several of them have been dragged into a report. So that's why we try to we should name them differently in each of the illusion that we are creating. So this is the SQL query or DDL that I would use to create a view called as order date. So order date key, so instead of calling it the date key, I'm calling it the order date key, right? Order day of week, order month. So everywhere I have prefixed order, right? As select date key, date of week key, date of week and month, and so on from the date dimension. So I mean, I may have some other attributes here, so accordingly I'll put them here, right, from date dimension. So this I have created a view order date, right? So this is a view order date that has been created. And now we have a package date. So package date, so these are the create view date. So this is the schema that I have given, and here I have prefixed everything with package, right? And as select date key, day of week, month from date dimension, right, from date dimension. So now if I drag, or if I pull out different attributes from these views into a report, and if I want to do an analysis like what is the average, right, delay between order and packaging, right? So if I want to do this analysis, I can do this very easily using these two views that are there with me, right? So I can find out the average delay between order and packaging. Similarly, I would try to find out delay between packaging and shipment date, right? And then I'll try to see which is the major bottleneck in the system, and then I may try to address that. So by keeping these things in place, like creating these views in place, I can do lots of analysis, different kinds of analysis on the data warehouse, and which can be useful in decision making. So now that we have 7 differently described time dimension. Differently described means the attribute names have been changed. They can be used as if they were independent. So now they are all independent in the sense that I can query them differently. I can put them in different. I can use them differently in the joins, right? And can have completely unrelated constraints. So I can put different kinds of constraints on them, and they can play different roles in a report. Now let us look at another example, and then I'll try to wind up by telling you something about the OLAP tools that work on top of a data warehouse in terms of role-playing dimensions. So frequent flyers, flight segment fact table need to include flight date, segment origin airport, segment destination airport, trip origin airport, trip destination airport, flight, fare, class, and customer. So now you can see here that the airport dimension comes many times. So segment origin airport, then segment destination, trip origin airport, and trip destination airport. So 4 references to the airport dimension are being made here, right? And then there are other dimensions that are there. So the 4 airport dimensions are 4 different roles played by a single underlying airport dimension table. So now a word about OLAP tools. So some OLAP products do not support multiple roles for the same dimension. So you have to then create multiple copies and deal with that. So you need to create multiple separate dimensions for multiple roles, and there is no other solution for you. OLAP tools that enable multiple roles do not enable attribute renaming for each role. So even if there are tools which allow multiple roles, but they do not allow attribute renaming, right? So either you have to do it yourself when you write the SQL queries, but that may become very tedious, right? So that is again a problem. And so most OLAP environments or most OLAP tools may consequently be littered with a plethora of separate dimensions. So since some of them do not support multiple roles, so you have to create multiple copies, physical copies. Some of them, even if they support multiple roles, they do not support attribute renaming, which again does not serve your purpose. So in most OLAP environments, you will end up having a lot of dimension tables which are not necessarily different, right? So a plethora of separate dimensions can be found in most of the OLAP environments. And with that, we come to the end of this particular lecture. So the next lecture is on factless fact tables. So here we try to model situations where there are no numeric facts to record. So with that, I end this lecture, and see you soon with the details on factless fact tables. Thank you.